In this video we'll look at an example of a type 3 rational function, and you can see the one in front of you there, and we'll go straight into it and we'll look for the obvious things, which are the y-intercept, which is in x is 0, so y is going to be 0 plus 3 over 0 minus 0, and we have division by 0. Okay, so x is infinite. So there is no y-intercept. That's the first thing. So when x is 0, y is infinite. Okay, and so there is no intercept. Let's have a look for an x-intercept. See if there's one of those. Again, what we're looking for is the x-intercept is y is 0. So we're going to have that, and again the denominator will multiply by 0, and we end up with that. So 3x equals negative 3, x equals negative 1. So when x is minus 1, y is 0 is a result. Now let's have a look at the next easiest one, which again we've done before, the vertical asymptote. So vertical and this is obviously when we're going to set the denominator to 0, and we don't, at that place we're looking for the asymptotes. This will factorize to give that. That will tell us that either x is 0, which is a result, or 3 minus x is 0. So this gives us that x equals 3. Note straight away then, type 3, we have two vertical asymptotes. Horizontal asymptote. And we're going to use the same method that we used before, and we're going to look at what happens when x gets really big or really small. And what we said was, let's have a look at the 4 terms, and there they are. And what we're going to do is divide through by the x squared. Now that is the highest power of this function. So what we do is we divide through by the highest power, and we end up with something very messy. It gives us 3 over x minus 3 over x squared all over 3 over x again minus 1. Now remember what we did before, we're saying that as x gets really, really big, so as x tends to infinity, y is going to tend to the first term. 3 over something really big is small. 3 over something really, really big squared is really, really small. Similarly, on the bottom, on the denominator, and we end up with that. So it looks like we've got 0 over minus 1, which is 0. So we've got a horizontal asymptote at y is 0. All right. Now at this point here, we could kind of graph things. Let's see what we've got so far then, and then let's have a look for the places that are going to be confusing. And this is what it's all about, really. It's a Sherlock Holmes type solve the puzzle. I'll give you lots of clues, and you come up with a solution. All right. Well, let's see what we've got. We've got a horizontal asymptote on the axis. So that's when y equals 0. We've got 2 vertical asymptotes. Again, it's on the axis. And the other one is at x equals 3. We have, as I remember, no y-intercept. If you remember, when x is 0, y was infinity. And here we've got an x-intercept at minus 1, 0. So let's put that one in. So minus 1, that'll be about there. So that is a definite crossing point. Now, interesting, look, we can cross a horizontal asymptote. but you cannot cross ever a vertical asymptote. So we've got 6 pieces now, 6 sections, if you like, on this graph, and we have to make sense of that. It's not going to go straight away. We're going to have to do some thinking now. And what we did in the last video, we just looked at the x-axis and we said when x equals -1, y equals 0. When x equals 0, we have an asymptote. When x equals 3, we have an asymptote. And so what we've got to do is look at the sections, okay? We've got 4 pieces to look at. Let's go when x is less than -1. So when x is less than -1, and we're going to look again at the positive and negativeness of it all. I've got 3x plus 3. I'm dividing that by 3x minus x squared. And we're going to look at what is y in terms of its positive and negative. Right, so x is -1. Let's look at something smaller than -1. Let's pretend it's -2. So when x is -2, on the top we get a negative result. On the bottom, the denominator, we're going to the first term is negative. The second term is negative squared, which is positive. So we've got a negative term, take away that other term, the positive term, so I'm going to end up with negative over negative, which is positive. So to the left of -1 is positive, which is interesting because it's crossing over that line. It's crossing over the actual asymptote. Let's worry about it later. Let's have a look and see what we've got. As I said before, it's just a matter of having a go and see what we can do. So let's take the next section. When x is between -1 and 0, when x is between -1 and 0, let's say -1/2, throw that into, oops, what's happened here? Oh, it's jumped up there, sorry. Okay, no problem. Come back to here, let's look at this now. What we'll end up with is negative plus a big positive, is a positive. And we've got a negative there and a negative squared, so that's going to be negative. So we have a negative result in there. Okay, keep going. We're looking at now between 0 and 3. And let's have a look now. So we would end up with a positive on the top. And let's say x is 2, for example. We're going to have 6, and that's going to be positive. So we end up with a positive. So that's positive. Again, thinking it through yourself as well. And try and make sense of what I'm doing. And when x is bigger than 3, y is going to be, now when it's bigger than 3 on the top, it's positive. And when it's bigger than 3 on the bottom, it will be negative. So it looks like we've got a negative section there. Ooh. So, tricky. We have, to the left of our graph, we've got an intercept here. It's going to go from positive down through to negative, but this is also an asymptote. So what it looks like is we're going to have something like this. Let me find another colour. Let's go with the purple. And let's make it a little bit thicker to see what we can get. We've got to go through the intercept. We know that it's negative between -1 and 0, and there's an asymptote which you cannot cross. So I'm thinking this. And I'm going to come through here, and as I go through here, it becomes positive, which makes sense. But it's an asymptote, so it's going to have to go like that. See what I'm saying? Looking at the middle section, from 0 to 3, it's always positive, and yet there are two asymptotes. Okay, so if it's always positive with two asymptotes, it's going to come down and then back up again. And now that's the little bit, the place where it turns and goes back is beyond the course at the moment. We need what's called calculus there. So I'm just basic sketching an idea there. And now what we're looking for is to the right of 3, it's negative. Okay, it's negative. It does cross the asymptote and it's negative. Well, it can't cross that one. And this time it doesn't cross the asymptote there. So that is what our graph will look like. Something like that. Okay? Done.